All right, so let's go ahead and start talking about query optimization. Specifically, I want to talk about how we can use something called an index to speed up queries in SQL. Now, the big highlight is this word index. If you've been writing queries professionally for a while, you've probably at least heard the term index, even if you haven't utilized one, and that's okay. So what we're going to talk about today is a general framework of how an index is commonly built out and try to kind of give an example of how it's used and some quick do's and don'ts. This isn't going to be the all-encompassing video on indexing. I'll probably end up making more videos in the future, so subscribe if you're interested. But this will give you a starting point. So at a high level, what is an index? An index is a reference. We can think of that as a phone book, right? If you're looking up John Smith in the phone book, you don't look through A, B, and C, right? You skip straight to S, and then you would go and find John by skipping to J. And so we want to do that same process in our lookups. And this reference has its own location on disk. This is important, but I don't want to touch on it too deeply right now. I'll touch on it a little bit deeper later on in the video when we talk about how we can utilize the indexes. So this index is two different data structures. So we have a doubly linked list and a B tree. Now, the reason we have both of these, so a doubly linked list is valuable for updates, and a B tree is for lookups. Now, remember that this index is stored separately from the table itself, so it does need to be updated separately from the table itself. So that's why we have to kind of keep this update idea in mind. So let's go ahead and talk briefly about what the doubly linked list is, and then we'll talk about what a B tree is, give examples of how they're used in the index, and then glue it all together and kind of talk about an example of an index. So doubly linked list. If you took a course on data structures, you've probably heard of this term before. If you're purely a SQL developer, you probably haven't, and that's okay. We just need to understand the high-level overview of why it's important, right? So say we have a series of nodes. A linked list is when the nodes have a reference to another node, like this. And that's valuable because it means that these values, say N1 and N2, don't need to be right next to each other in storage. They just contain a reference to the other value. It's a doubly linked list when each node contains a reference to the previous value as well. Okay? Now, the big benefit here is if I want to create node 4, and I want node 4 to be in between, again, node 1 and node 2, what I can do is I can simply change the references of node 1 and node 2 to map with node 4. So, quick example, let's go ahead and do that. We would change node 1 to map to node 4, and node 4 to map to node 2. And we would set node 2 to node 4, and node 4 to node 1. And that's all we have to do to update that. So if we're doing an insert, this may be a faster way to insert. So how is this used in the index? Well, the index has something called a leaf, and I'm just going to call this value an ID, and we also have a reference. And typically we're going to have around 3 identifiers in each leaf. So let's go ahead and do that. I'm just going to create 2 leaves for this example, for time's sake. Okay. Now these leaves are then connected as doubly linked list. So this leaf is the node, and this leaf is a node. You can consider this N1, you can consider this N2. Okay, so the big benefit here, again, is if I needed to create an N3, I can simply change the mapping and make that update. I don't have to restructure how the data is sorted. Okay. Okay, so that's kind of the high-level overview of what the leaf is. I'm going to leave that here because we're going to come back to this image in a second. Before we do, we need to learn about the other data structure we're going to use, which is the B tree. Now, even if you've done some data structure work in the past, you may not have heard the term B tree. A B tree is a balanced tree. And it's definitely not a binary tree. So what we need in a B tree is that all the depth values are the same. So let's give some examples of balanced trees, right? So if we have this tree, that's good. If we have this tree, that is not good. And if we have this tree, we're also good. And the big benefit of having this balanced tree design is if we were to look up the index, this movement is in log of n time, which is much faster than searching through all available records. So let's go ahead and go back to this image and let's kind of build in that balanced tree format. So what I could have here is, let's go ahead and create another leaf. We have 7 to 9. We have a reference. Okay, and these are all connected as a doubly linked list, so we can do our updates as needed. Okay, and then we have another value here. And this node contains the highest value from each. So we have the highest values ID3, ID6, and then lastly we have ID9. Okay, so we can connect here and here, here, and then we also are going to have a node up here. This is going to be our root, and this root is going to have the largest. So we have ID9. It's going to connect here. Now, in an ideal world, right? So this, or I guess not in an ideal world, in reality, right? So this would have 3 different nodes coming off of it. And each of these nodes will also have 3 leaves. But for the sake of time, we're just gonna look at this one up here. And it's important to note that even though these are in different nodes, these would still be connected via the doubly linked list, right? So the doubly linked list goes through this whole section. And so now we can do our updates and inserts as we were talking about, and our deletes as we were talking about, but we can also traverse, for example, if we want to get to ID 7, right? Instead of having to go through ID1, ID2, ID3, etc., you can go check. Oh, is it less than ID9? Okay, good. Go over here. And then, is it less than ID9? Yes. Is it greater than ID6? It's greater than ID6, so it's not going to be this way. It has to be this way, right? So, and in 2 steps, basically, we reached ID7. And then you would just have an O of n traversal between ID7 and ID9, which is much faster than going through all the values in general. So that's the idea of how the index works. And typically the way you'll see an index being used is you may have an index. Again, if we think about our table that had ID C1, C2, C3, etc., right? And we have an index, an ID. We write our select statement. Which is select the ID in the first column from table where ID equals 73. We have then optimized this part of the query. You could also additionally have indexes on any column. There's no reason why you couldn't do an index on C1 or C3, or a combination of ID and C2 and a combination of ID or C3. The big gotcha here is that you want to limit the amount of indexes that you're actually using. And the reason why is if you have a bunch of indexes, each index needs updating, which is super important. So if you have 40 indexes, every time you do an insert into a table, you have to update every single one of those indexes, which will slow your query performance or your update performance to a crawl, right? So it's kind of a fine line you're looking at here. You want to index on frequently used columns, but not all. And that middle ground is kind of tricky. It really depends on the database itself and what the table is being used for. So that's a high-level overview of what the index is. Again, so if we were to wrap this up, an index speeds up queries, it's made of a doubly linked list, and a B tree, and it can be overused. And so that's kind of a high level overview of what an index is and how it's going to be used. I do plan on making more videos related to indexes in the future in query optimization, maybe pull out Postgres and actually build out some indexes to look at some explains. Additionally, if you want more information on indexes, I recommend SQL Performance Explained specifically by Winand. Which you will be looking at chapter 1. Or if you already have Kleppmann, he also goes into some details about indexes in, I want to say chapter 3, but that's more of a high-level overview, and he talks about a handful of different indexes. So you're not going to get this kind of detail, and that's data-intensive applications, or designing data-intensive applications, which I'm just going to refer to as DDIA. So those are two different references if you want to learn more about the topic. Otherwise, feel free to like and subscribe. If you enjoyed this video, greatly appreciate the like. And hopefully I will have some more videos out on some other topics in the near future. Thank you so much.